Alright, we have a cylinder inscribed in a cone with a radius of 6 centimeters and a height of 10 centimeters. So that 6 and 10 is the height and radius of the cone, the outside one, and the radius is r for the cylinder and height is h. So you can look at this diagram and you can of course create that on your own. So we first have to figure out what we're trying to maximize or minimize. So let's say we want to maximize this volume here. Okay, so the volume equation then is pi r squared h. Right? Now our problem again is pi is a constant, so that's okay, but we have r and h, and the volume is in terms of r and h. So we have to somehow write one variable in terms of the other. So you can have just equation of volume in terms of one variable. So if you look at it here, look at big right triangle on the side. Okay, this whole thing is 6. Here's r, and this whole thing is 10, and this much is h. So this is 10 minus h, right? So you can set up a proportion 10 to 6. So this whole side to this is going to be 10 minus h over r. So once you do this, you can say, okay, well, 10r is equal to 60 minus 6h, and r is equal to 60 minus 6h over 10. Or we can simplify and say 3 over 5 times 10 minus h or something. Yeah? Alright, so, or it might be even easier later if you just leave it as 30 minus 3h over 5. Okay, so then because I know r is equal to this expression in terms of h, I can plug this in here. So v, I'm going to change colors. So v now is equal to pi times 30 minus 3h over 5 squared times h. Okay, and you could factor out. You could factor out 3 over 5. So because this is 3 over 5, 10 minus h, and you're squaring this whole thing because that's r squared, you can think of it as pi times 3 over 5 squared times 10 minus h squared h. Okay, so volume is pi times, or actually 9 pi over 25 times 100h minus 20h plus h cubed. Okay, if you distribute this out, this is what you're going to get. So that's my volume equation in terms of the height of the cylinder. Okay, let's extend the page a little bit. Okay, so that's my volume equation. Now, let's find the first and second derivative of this. So first derivative, dv dh, is going to be, this is a constant, so it'll just stay. And it'd be 100 minus 20. I'm missing something. Yeah, there you go, squared. So 40h here plus 3h squared. That's my first derivative, and the second derivative, it's going to be again 9 pi over 25 will stay out, and you will get negative 40 plus 6h. Or you can even write, factoring out a 2, 18 pi over 25, and then 3h minus 20. Okay, that's my second derivative. Alright, now I need to find some critical values. Okay, I need to find some critical values, and that's when the first derivative is 0. So I need to factor 3h squared minus 40h plus 100. So how will they factor out? 3 and 10, that's going to be 30 and that's going to be 10. They could both be negative. So 3h minus 10 and h minus 10. So those are my two values. So dv dh is 9 pi over 25 of this. So these two are equivalent statements. And now my critical values are h is equal to 10 and 10 over 3, setting these equal to 0. So those are my critical numbers. Alright, so I need to find out if this is going to give me a maximum or minimum. Luckily, we already found a second derivative. So we just have to plug in the second derivative of v when h is 10. What does that give us? So this is always positive here, so we don't have to worry about that. This is always positive. And then 3 times 10 is 30 minus 20, that's going to be positive. So that means local min, because your second derivative is positive, is concave up, that must have been in local min at h equals 10. And second derivative of v at 10 over 3. Okay, if you plug in 10 over 3, that's going to be 30 over 30, which is 10. 10 minus 20 is negative, right, in a local max. H equals 10 over 3. Alright, so max volume happens, the maximum volume, when H is 10 over 3 centimeters. Okay, and what is the height then? Well, we know the relationship between R and H. That was 3 over 5, 10 minus H. So you plug in 10 over 3 in here, and you get so we 30 over 3, 20 over 3. This would be 4. So the volume is maximized when the radius of the cylinder is 4 and the height of the cylinder is 10 over 3 centimeters.